My name is Scott Bailey. I'm a professor at Virginia Tech. I'm in the Department of Electrical and Computer Engineering, and there I study atmospheric science. I'm the principal investigator of the PolarNOx mission. This will be the second time we're trying to measure nitric oxide in the polar night. We're here at Poker Flat. This is a polar winter measurement, so we need to be somewhere where we can see into the polar night. Poker Flat's just outside the polar winter, but we can view northward and see where we need to see. It's actually perfectly located for what we want to do. We're here to make a measurement, one of the first, not the first, but one of the first measurements of nitric oxide in the polar winter. And the way we do that is we use a star as the light bulb. And we have a telescope with a spectrograph. We lock onto the star, and as the rocket goes up, we observe the star, and as it comes back down, that gives us an altitude profile. So we see nitric oxide concentration as a function of altitude. The thing we've learned about the Earth's atmosphere in the last 20 years, the big evolution in our field, is that it's one atmosphere. We grow up, we learn, and there's a stratosphere, there's a thermosphere, there's a mesosphere, there's all these things, but the more we learn, the more we see they're coupled. There's one atmosphere. And the aurora creating nitric oxide eventually leads to changes in ozone concentration. Changing the ozone changes the winds. And so what you get is, by the aurora creating nitric oxide, you get changes in the whole Earth system, right? If you change how much nitric oxide in the polar winter, a lot of NO means less ozone. That means less cooling, warmer atmosphere, so lower winds. So there's a big connection from what's happening up here to what's happening everywhere. And we're trying to understand that full system. I love doing this work, and I love every aspect of doing it. It's adventurous. We're here in Alaska. It's remote. We're flying something in space. It's just beautiful and it's cool. But I've been doing this a little while now, and as fun as that is, building things that fly in space, there's not much better than that. There's nothing better than seeing the data. When you've been working on it for years and you have this question and you're focused on it, how much nitric oxide is there, and you've estimated, you've calculated, you've tried it, there's nothing better than seeing that come in and knowing you have the answer and getting it. And almost always we're surprised, right? It's awesome. That is the best.